Hello, everyone. Thank you for listening in on this short video of moving machine learning from experimentation to production. This is the second part to our Stages of Your Analytics Journey series, and my colleague Robbie would have taken you through the tools that are required to get started. And here I will take the conversation further with describing MLOps. As a quick introduction, my name is Raghav, and I'm a data and analytics consultant at Thorogood, and I'm based in our UK office. I've been with the firm for over 6 years now, and in that time, I've helped some of the world's leading firms with their data and analytics strategies. And increasingly, those strategies are cloud-based, and more increasingly, they involve considerations for AI and ML. So I'm going to dive right in here. There is a gap that exists between the investment that organizations are making into machine learning and the realized benefit and the value that they're able to derive. And that is caused in large part by the inability of most companies to shift from experimentation to a productionized state. We're seeing businesses invest in experimentation, exploratory, ad hoc analytics done in sandbox environments, which are often local and non-integrated. This is great, and one would almost say that this is necessary. In fact, rapid experimentation is a key indicator of a healthy, robust, and dynamic analytics-driven organization. But where we're losing out on our investment is the inability to operationalize those experiments to something that is enterprise-ready and robust enough to affect change. The reason for this? Well, I think there are fundamental differences in the needs for experimentation and the operationalization of ML solutions. This could range from flexibility in tools to the skill set of your data scientists and your ML engineers, as well as several other factors. So I think it's important to understand that there are not two discrete things. It's important to understand that these are not two discrete things or states. What we're leading to here and what we are building is MLOps. When we set up an MLOps framework, we're actually doing our experimentation within an operationalized system. So what does that look like? What does that really mean? Let's break down the typical MLOps project lifecycle to give you a bit more of a basis. So in our first phase, we look to define. This is where we understand our business needs and define a viable proof of concept. An example of a proof of concept could look like, an organization looking to simplify their product portfolio from the lens of sales volume, market growth, margin, and supply chain costs. Another example could look like an organization understanding how their innovation is performing, looking to detect potential opportunities in growing segments. So having defined a proof of concept, the next stage is to experiment. So this is where cleansing, normalizing, imputing, feature engineering selection with input data occurs. We prototype and experiment with modeling approaches and evaluate results. The output of this step is a trained model that is suitable for productionizing. Not all experiments end up going to production though. For those who do, you go on to industrialize them. And here we would refactor experimental code for scalability and create automated CI/CD ML pipelines. Plus, we would develop and test automated model monitoring capabilities. And finally, the idea is to monitor and improve. So perform ongoing monitoring of your ML system and track model performance to stay ahead of drift and model decay. We also gather feedback from end users at this stage to continuously test and integrate improvements. The critical component here, or one of the critical components, is that our experimentation is embedded and ingrained in our productionized lifecycle. So that hopefully sets the basis for what MLOps is. Now I would like to walk you through 4 key benefits of MLOps that bring the most value to the business. One of them being increased accuracy, trust, and awareness. The second one being the empowerment of data scientists. The third being the ability to uncover value quicker. And the fourth being the ability to manage costs. MLOps proves to be extremely beneficial when considering insights, accuracy, trust, and awareness of the data science work that is taking place within an organization. When we implement MLOps properly, we are building in a framework of auditability, monitoring, and responsiveness. Essentially, we're providing a little bit of transparency and insight into what has long been treated like a black box. We can monitor our data for drift, we can monitor our models for degradation, and in general, we're keeping the pulse on the health of our ML algorithms, and really that entire life cycle which I talked about earlier. The ability to monitor is really a means to respond to data changes, to respond to model degradation, to respond to changes in business problems. We want the ability to evolve the model to incorporate anything that's happening, and we can only do that if we can see what's going on. In this way, MLOps is an immense benefit to the business because it's increasing the accuracy of and our trust in our ML models. And on top of that, it's giving us the opportunity to respond and evolve. So incorporating an MLOps framework and architecture that supports enterprise scale machine learning allows for the automation of processes that were once a huge overhead for data scientists. This will empower data scientists to perform even more valuable analysis by using tools that support greater scale, faster processing, and wider functionality. And also allows them to spend their time instead on adding new features to existing models and innovating to solve other business challenges. For example, when working with the rest of the data team, the models that data scientists create, which may have long run times, could be re-engineered to take advantage of an enterprise architecture that provides greater parallelization options, allowing strands of the model to be run simultaneously and processing times to be dramatically reduced. Automation here also presents quite a few other benefits to the business. Automating the support and monitoring capabilities reduces the risk of manual or human error and also presents the opportunity for scalability across your organization. By applying this automation to models, you can fit and tune across tons of different cuts of data, which really would have never been possible for just one person to do. Another one of the key benefits of an MLOps framework is the speed in which value can be realized and ultimately used to make decisions by the business. It's clear that the manual activities that are done by the data scientists take a considerable amount of time, and that could be better spent on innovation and improvements to ML models elsewhere. There is, however, obviously another side to this coin, and that is the time lost by business users to use model outputs to inform business decisions. In retrospect, had experiments at organizations been productionized with MLOps principles in mind through its inception, model outputs would have inherently been more valuable due to predictions being coupled with great speed. It's probably easiest to see this value demonstrated through an example that we've seen firsthand at one of our clients. This particular client had a trove of manual activities that were required to refresh model outputs due to the nature of how the experiment was designed in its data preparation, data modeling, and model generating steps. So much manual effort that in fact, at the beginning of every month, it took roughly 7 days to actually refresh the model outputs so that they were interpretable by the business. Obviously, this effort takes a toll on data scientists, but also affects the business too, as it takes them quite a long time at the beginning of every month to get their hands on the model outputs. When Thorogood worked with this particular client in bringing forth this ML experiment into an MLOps framework, the model outputs could be received by the business stakeholders approximately on the first day of the month rather than on day 7. This week of extra time gave stakeholders more time to interpret and formulate analytically based decisions on the same model outputs, but so much sooner. From a competitive standpoint, this additional week of time is critical. If an organization can drive insights quicker, particularly from an analytical perspective, then that organization can beat competition that may be slower to reaching the same insight. This additional time could also ultimately be the difference between a winning and a losing strategy in the market. And finally, management of costs. Costs are at the forefront of everyone's mind. With a proper MLOps framework implemented, traditionally expensive solutions can be minimized to things with sound cloud infrastructure principles, cutting down on compute costs through parallelization and optimization, and improved data management principles and handling of tech debt. ML solutions are compute heavy. Odds are that they are coupling many different data sources together in the magnitude of millions of records and subsequently generating an ingestible outcome for the business. A hidden cost that is familiar with those working with traditional software engineering projects, technical debt, is something that must be managed appropriately and can be done so with the help of a defined MLOps framework. Without careful consideration in the experimentation stage, seemingly hidden maintenance costs can manifest themselves in ways that can compromise the value returned by an ML experiment. Some examples could be something like changes in master data that are driving outputs, or redundant or inefficient data engineering pipelines, or even the difficult to quantify manual efforts that should be replaced by automation. It's not feasible to measure every piece of debt that is incurred by an ML project over its lifespan, but to mitigate as much as possible in the development stage through a defined MLOps framework will make paying it off much cheaper in the long run. So having talked a little bit about the key benefits of MLOps, I thought I'll leave you with some food for thought. I'm going to attempt to define the 4 main pillars that form the backbone of a successful MLOps implementation. These would be people, so as to what skills does your team need, how many people do you need, what roles do they play. Secondly, processes. So how do you keep an MLOps implementation going? How do you move from the ad hoc experiments run by data scientists to productionizing their models? Thirdly, tools. So what tools should you use? What is the optimal technical design? These are some of the considerations to think of. And obviously data that underpins everything you're doing with machine learning. I'm going to actually also take this a step further and spend a moment on tools and elaborate a few key aspects and what they would be. Firstly, automation. So CI/CD techniques and parameterization coupled with automated triggers play a key role in an MLOps framework. So your tools need to consider for that. Secondly, parallelization. So leveraging Spark-based platforms to move from processing sequentially on a single node to parallelizing operations on multiple nodes is of essence. So again, the tools need to be able to cater for that. Next, we have our inferencing approach. So if you're going down the batch inferencing route, you could factor in the relatively lower demand and load in your tooling choices and incorporate parallelization in your ML pipelines. Whereas with real-time inferencing, your ability to scale and handle a high volume of requests is the top consideration when designing your serving architecture. And finally, model monitoring and metrics. And these should look to give you the technical health of the model and its predictive quality. And your tool should be able to generate these metrics and present them as well. So I've talked about quite a bit there on my last slide. And if you're wondering how to get started, we can definitely help. At Thorogood, we have experience in strategizing and implementing MLOps frameworks at the organization level. Having a baseline of where the organization stands from an MLOps perspective is obviously the place to start. And upon gaining this understanding through a readiness assessment, it makes sense to subsequently strategize next steps and implement some of the more technical aspects that we have discussed in this webinar. If you're interested in learning more as to how Thorogood can help implement an MLOps framework within your organization, please feel free to reach out to me and I would be happy to discuss this with you. That'll be all for today. Please feel free to reach out to me on my contact credentials provided here. And thanks for joining in.